like I should be singing and dancing. Okay. Okay, video? Hey, okay. So I only invented this talk, I had the idea a couple of months ago, and thought, yeah, I've been working on this stuff for a long time. And then I got as far as having an outline a few days ago, and then I've been frantically writing slides, and I now have 67 slides for a 40-minute talk, so I better get moving. One of the amazing things about this whole logging scene is that there's a lot of pieces that are interchangeable. So there's a lot of options for each part of the pipeline and the way you do things, but I'm not going to talk about those. I'm not even going to talk about how we picked the ones that we are using. I'm just talking about our journey. And when I started at the company I'm at now, Tiger Lead, 2008, there was very little logging. Things would run and they'd write to stood out, and then you'd exit from the machine and the logs would just vanish. They'd go to DevNel. So if something went wrong in production, what the hell's going on? And you had no visibility at all. So bit by bit over the years, I've been working away. Hello, Andreas. I've been working away to improve this scenario. And now we capture lots of logs, and it's all awesome, and I thought I'd write a talk. I'm not claiming any of this is best practice. This is just the journey that we took and where we ended up. So I hope you'll find a lot of useful things along the way. So the first thing I wanted to do was add some sort of logging API into the application code. I settled on log for Perl for no particular reason. It was just the one we chose. Wrote a few little utility functions to be able to enable logging and create a log file. Intercept the warnings, all very simple stuff. Very standard sort of log for Perl configuration based on the log4j Java background that it comes from, and you'd end up with messages like this. So this specification here, we've got the time, date and time in a sortable format, priority, the message, and then this was the file and the line number and the subroutine name, just appended on to the end of the message. And this was great, We had log files, but it also wanted to capture warnings. So what this does is it puts in a hook on the warnings, and it says, down here it logs the warning, but there's a bit of extra code here to say, well, if I'm already recursing into this, and this generates a warning, I need to stop. I need to protect against an infinite loop. And if log for Perl itself isn't set up, then I need to protect against that, so just return a warn. That's grand, so now we're intercepting warnings. What about fatal exceptions? This is pretty much the same, but up here we say return if we're in an eval, so we're going to get caught, so don't worry about that. Or if we're parsing, if an exception is generated while loading a module, then we don't want to get into this, just die. So that's all grand. We had a lot of batch jobs that would run and they didn't have decent error handling, and they should fail but didn't. So what I did was put in a logger that would just be a little ring buffer of recent errors. So when the batch job ended, it would say, well, I don't know what's happened, but did any errors get logged? And if they did get logged, then it would say the batch job failed. And that proved to be a simple fix for that problem. So now, progress. We have timestamp log messages with severity. We have per app log files. We can tell if warnings or errors were generated, but we're not capturing stood out. So if, for example, we launch a subprocess, we have no record of the output from those. So this was the situation when I started, and we've now got to here. Progress. You'll see lots of extra space on this diagram. So how do we capture all the stood out and stood error? Now that's a little more tricky than it seems. We run all our production stuff under as daemons, so you start them up and they all run. And what setsid does is it puts the daemon starting stuff in a separate process group, so it's detached from the terminal. And then we capture stood out and stood error and pipe it into something that captures the logs, which also is in a separate process group. And these separate process groups allow us to check whether anything is still running in that process group. and also to send a signal to an entire process group, which turns out to be very handy. Now for us, we use daemon tools, so we start daemons using this service scan, and we capture logs using multilog. What multilog does is it captures the logs, writes them to log files, and looks after rotation for you. So we're saying we'll keep 100 files, maximum this size. The T there puts a high precision timestamp at the front of the log. Now the nice thing about this is that even if these daemon commands, if they launch subprocesses and they fork things and then die themselves, but the children are still running, because this log capture is just going to live until the std input is closed, it'll keep running. No matter what happens to these daemon commands, it'll keep running until every child process has closed its std error. So it's a very reliable way of capturing the logs. So now we have our common logs being called. But we still have to log into every single machine to see what's going on. We have no single place just to watch the system. I also wanted to start parsing the log messages to extract useful information. Now at about this time, Elasticsearch was becoming popular, and Logstash was also becoming well known, and Kibana. So this would look like a good solution. I'll demo these tools later. So Logstash is a way of collecting, manipulating and forwarding logs. It's just a streaming thing. So there's no storage going on. And we stream the logs into Elasticsearch, which is a very nice distributed real-time data store. Fabulous. Show you that later. And then we use Kibana to view the logs. Elasticsearch, lots of inputs, all sorts of ways of getting stuff in, all sorts of ways of interpreting what comes in and formatting what goes out, all sorts of ways of processing. This isn't really filters, they're ways of editing the messages as they flow through, and then lots of ways of forwarding it on. So we use syslog TCP input mostly, and we use a bunch of these filters that I'll show you shortly, and then we output into Elasticsearch. So Logstash configuration looks like this. It's a kind of a DSL. Logstash itself is implemented in JRuby. So you declare a bunch of inputs, you declare a bunch of filter processing blocks that do various things, and you declare your outputs. There's, I think, a thread for each input. There's a thread that runs the filters, and you can control how many filter threads you have, because that's usually the slow bit. And then there's one thread per output. In between these are buffers, and the buffers only store about 10 messages. So within the Logstash process, at any one time, there's only about 20 messages being passed through. Elasticsearch. Elasticsearch, oh, it's full of awesome document-oriented, schema-free, JSON in, JSON out. It's very buzzword compliant. If anybody knows anything about Lucene, it's like Lucene on steroids. In fact, it's like lots and lots of Lucenes flying in formation. It's fabulous. Distributed, massively scalable, blah, blah, blah. It's just generally awesome. Kibana also is genuinely awesome. That's just a screenshot I grabbed. It's not actually what our dashboard looks like. Our dashboard is very boring by comparison. But it allows you to put these things together in minutes. And then all of this is live. If you click on anything here, stuff happens. Lots of awesome. So we started out with a single machine, and we ran Logstash, and we ran Elasticsearch, and bit by bit we kind of started feeding more and more logs in, and eventually now we're running on 3 machines, and we have Logstash, Elasticsearch and Kibana running on all 3. All 3 work together as an Elasticsearch cluster, and then a HA proxy at the front that will route the incoming logs to whichever backend it wants. So now we have this over here. Fabulous. We need to start throwing things into it. So the first thing to put into it was syslog, because we already have syslog, gathering system logs. So it's very easy just to forward the system logs in. Straightforward stuff. Now we use CentOS, so we have our syslog. I think the syslog that came with CentOS was fairly old, so we've upgraded. We're on 6.7 now. There's an 8 point something out that we'd like to upgrade to. We started timidly just forwarding notice severity and higher, so notice and warning and error and above. But now we just throw everything info severity or greater. Syslog formatting. Forget this for now. This is the main bit. We're just saying everything of info level or above, send it on to our logstash machine and use this format. Now this format gives you high resolution timestamps and time zone, I think. But it gives you a high resolution timestamp, which is great. We use TCP, not UDP. Why people send logs using UDP, I don't understand. Well, UDP within a machine, fine, then store and forward reliably. Because if something goes wrong, if your systems are, have some problem that is swamping the system, and you're trying to diagnose it, and you're looking at the logs, you don't want to have in the back of your head the question, have I dropped some logs that would give me the answer to what's going on? Yeah. So to actually move data between machines, I wouldn't use UDP. Use UDP within a machine, much more reliable. Okay, so now we have this. We have system generating stuff going into our syslog, gets forwarded. If this is cut or logstash is down, our syslog will automatically queue for us. So that's what this bit is doing here. It's saying queue the stuff, save on shutdown, linked list, so it's all asynchronous, keep on trying. That's what gives you reliability if something bad happens. So you don't lose your logs. Now our syslog itself looks a bit like, in terms of functionality, looks a bit like logstash, in that it has all sorts of inputs it supports, all sorts of outputs it supports. We essentially do nothing except the very basic input and then forwarding to logstash and log files. So we've got the system logs going to logstash, but what about our logs? We want to ship those. Now, I had the idea that we were going to be parsing the log messages from our apps. So I didn't want to do that on the central server because A, it would put more stress on the central server, but B, if we upgraded the software on one machine, we'd have to upgrade the log parsing in sync. So that would create a problem for us as we were rolling out releases. If they changed the logging format, we'd have to synchronously change the parsing. So I thought, no, we should do the parsing on each machine that's generating the logs. So use the message parsing framework on CPAN and wrote little parsers that would read the log files, parse it, convert it to JSON and ship it to logstash. And that was great, but we never really did very much parsing. And I was never terribly happy with the 0MQ support in, oh yeah, we use 0MQ to actually ship the logs. Never terribly happy with how that worked. So in the end, we ended up switching to running another rsyslog daemon that just forwards to the local one. So that's how we started out with 0MQ shipping. And what we do now is we have rsyslog reading the files and forwarding it here. Now the reason for this is this rsyslog runs as root. So we didn't want our apps configuring the root syslog because that would be a big security hole. So we run this rsyslog daemon as our unprivileged user, and then you can happily configure it to do whatever you like, and it just forwards the logs. So that's sweet. Now, having got this far, we have a bunch of system logs, and we have application log files. But it's kind of hard to correlate between the two. They have different timestamp formats, and they're in different directories, and it was, I'd often be sort of grepping two lots of files just to see what's going on. And I was wondering, could we just use syslog for everything? And rather than have our apps have Perl code to manage log files, could we just ship everything into syslog and let syslog write the log files for us? And what I wanted was to have per application log files, have a high resolution timestamp with lexical ordering. This turns out to be really useful if you're generating lots of logs. You just want to be able to do a merge sort on a whole bunch of log files that you're interested in, and very efficiently sort of order all the messages from the different files into time order, and let the system look after log rotation. So What we did was we tweaked our log for Perl config again, and we set up a syslog appender, and we said, well, just send all the messages to syslog. Now, the previous rsyslog format was kind of dollar variables. That's sort of the old style. This is the new style, modern rsyslog config. It's technically called Rainer script. Here we're setting up a template for log messages, and the output looks like this. So you've got a high resolution timestamp, which is in lexical order. So you can just sort that, and it comes out in time order. You've got the facility, the severity, the program name, and the message. That gives you that. Here's another template. This one is for file names. So here we take the program name, and so this program name, for example, would come out as var log tiger run parts. Basically, it just truncates everything after the first character that is not sort of safe, normal character. Here's a rule set. This is like a subroutine in rsyslog, and it only does one thing. It says write to a file using this file name and using this file name and this format. And then here we say any messages that come in that have severity of info or higher, and syslog uses this crazy numbering scheme, so lower numbers are higher severity, except some list of programs that are a bit too noisy. Call this subroutine to write the output. All a bit long-winded. All these slides will be available, by the way, so you don't have to take all this in. So now we have this. We have the apps writing directly to rsyslog, and rsyslog writes the files for us. And all this happens asynchronously and very fast. So we're likely to get rid of these files soon, because it's just Perl spending its time writing stuff that it needn't worry about. Any questions so far?
It might be a bit too far off topic. Have you considered writing JSON directly?
It is. Have I considered writing JSON directly? And the answer is yes, and I'm going to talk about that shortly. Okay. So, what's Logstash doing for us? Well, at the moment, it's not doing very much, but we have lots of machines with a host naming convention where the first word of the machine name is kind of what the machine's about. So it would be handy to get Logstash to add an extra field into the data as it flows through with that host, what we call the host group. And also another simple one is punctuation. If you extract only the punctuation from a message, you get a kind of fingerprint for that kind of message, which is just a very simple way of filtering in or out particular messages. So, time for a quick demo. Okay. So this is our, hey, you can actually see it all. And I even have room to expand. This is the first conference I've ever been at where my screen didn't shrink when I plugged in the video, which is great. So here's our dashboard. I haven't spent a lot of time customizing it because I know there's a new version of Cabana coming out, which is going to be even more awesome. So we have query at the top, filtering at the moment. We're just saying, give us the last hour. This is actually live production data. So to refresh, and you see you get these spinny things and da-da-da. This is what's happening. Severity. Actually, if I do it this way with the mouse pointer, you've got severity, info messages, warnings, notice, host group. Now, at the moment, this is all in America, and America, it's nighttime, and during the night, system sends out lots of emails. So there's lots of messages coming from mail dispatch, various systems. Program, HA proxy, you can see postfix there, handling the mail. Syslogs and tags I'll talk about later. And then here's just a count. Now, what am I going to do? Yeah, we're going to focus on HA proxy. I see I just click on that pie chart segment, everything updates. So here I'm only looking at HA proxy messages. And you see various systems here, info, a little bit of warning. Now, what I'm going to do is I'm going to say I want to see everything except HA proxy. Everything refreshes again. And now you can see program here, lots more mail stuff running at the moment. Also, I can zoom in if there's a particular spike. I can just click and drag there. And you see it adds a filter for the time range. And I can zoom in again. These filters I can turn on and off just with a toggle, and everything refreshes. Now I can go severity label error and severity label warning, and now you can see the graphs, the chart, warnings and errors. This is all very handy, as I'm sure you can imagine. Now, if you drill down to focus on something in particular, you can then get a URL and you paste that to your co-workers and say, hey, look at this. They click on the URL, they see exactly what you're seeing. This is awesome for just being able to communicate with a distributed team without saying, hey, come and look at this. So that's all great. Okay, so we no longer have to log into machines to see what's going on. We can easily drill down, we can share URLs. Fabulous. Life is good. But, you know, it's not quite great. You have to keep looking at this screen, see what's going on. Wouldn't it be great if we could live stream the errors? Let's live stream the errors to IRC. Wouldn't that be cool? So we use IRC a lot, and so we set up 2 channels, one for production, one for staging. We currently log just the errors because we started with these warnings, but there were just too many warnings. Also, anything with alert or emergency severity gets routed straight through to the main developer channel, so everybody knows about it. And this has proven to be incredibly useful. But IRC, occasionally if there's a problem in production, you'll get a flood of messages and it just doesn't work very well. IRC is rate limited, but the rate limiting is dumb. You know, if you've got a flood of a particular kind of message, you can lose a whole bunch of other stuff that's more useful. So what we wanted to do was rate limit only on repeated messages. So you want to rate limit particular messages that are coming through too fast. But it shouldn't be duplicate messages because there might be variations. If the message had, for example, a floating point time, well, that's always going to keep changing. So let's see if we can put logstash to use for us here. So this is a thing I invented called a message gist. And the idea is that you take the message and you copy it into another field, and then you normalize the message in various ways. So you replace all floating point numbers, or any kind of number with an N, replace double quoted strings with an S, replace single quoted strings with an S, taking care of apostrophes, kind of tricky, but good enough, and also take off any query and fragment from URLs. And then take that and convert it into a murmur3 integer hash. Okay, so that's a fingerprint of a kind of message, the gist of a message. So that's cool. Now, the next thing is we can use this throttle filter to say, well, okay, if it's something significant that we're likely to care about, then put it through this throttle filter. So for every period of 60 seconds, allow 2 messages through that share this fingerprint. So here we have the message gist with program severity and the host group. So similar messages coming from machines of the same group will still be counted the same. So if you suddenly start getting a flood of the same message, you'll see 2 of them, and then silence for 60 seconds, and then 2 more. And so we know, ooh, look, that's happening a lot. And we also add a repeat tag, which we can show. Now this is great for the purposes that we're using it for. I'm planning to add another one that's a more strict sort of duplicate tag with a much smaller period. Because, for example, with HA proxy, we have 2 HA proxies, a kind of main and a standby. So we get messages from both, but they're kind of important messages. Whereas if we put in this mechanism, we can then filter out the duplicate that's come from the standby. So the next thing we do is we say a late tag. Sometimes if the machines are flooding messages, they'll get queued up because the syslog, the logstash can't cope with the rate, in which case messages come through late. But if a message comes through late, you don't want it to go to IRC because that'd be confusing. So what we do here is this is a Ruby. You can put Ruby fragments directly in if logstash doesn't offer what you want. So here we take the age of the message, and if it's more than 60 seconds late, we tag it as late. If it's 60 seconds in the future, then we go, hey, that's strange. Tag it as early, usually like clock problems, whatever. And if it's got one of those tags, then we tag the event, and we also record the age in the message. We add a field. So now we can do sensible IRC streaming. We say if it is important enough to think about sending to IRC, and it's not a repeat, and either we don't have a delay or the delay is less than 10 minutes, so it's not too old, then put it through to the production log stream. We use a 10 messages per second throttle there. Format like this. So that was the message that you saw earlier in that example. For emergency and alert messages, then we send them through to the main developer channel. This works really well. So a lot of people now, a lot of developers are starting to spend time on that channel. So this is now Logstash is sending messages to IRC. This is cool. So we live stream to IRC, and that promotes awareness of the production system. And developers start to get more interested in reducing the rate of warnings and errors, mainly because I embarrass them and say, hey, lots of messages from your system today. So they're kind of becoming more aware of the production environment and the kind of problems that we encounter. But we often get this question. So if there's like an uninitialized variable warning, well, what was the code doing when that happened? You know, these kind of things can be very hard to understand what the cause is, or what web request was being run. So we need more context. So how do we get context? So my original thought years ago was that we just bung more fields into the message and then parse them back out. But it means that all the messages get longer and longer, and it's hard to see what's going on. For now, what I thought was, well, let's start by capturing all the HTTP logs, because that would be a good start. Now, we could do log shipping, we could write log shipping for every single web service we have that writes an access log, and we could read the logs and ship them. But all our web services pass through HAProxy. So let's ask HAProxy to send us all the logs, and then we instantly have access logs for everything on the system. So that was easy enough to do, and HAProxy also enables us to, we can configure it to send us the request and response, one request and response cookie, plus request and response headers. So we settle on this configuration, TCP log. So every TCP connection generates a log message. This is, don't have to worry about the details here, but this is basically everything that might possibly be useful. HTTP, same thing, same format, except that we add a whole bunch of HTTP specific stuff, and then we ask for the referrer, the user agent in the request, and the location in the response, and we log the session cookie. So what you get out is this kind of stuff. So that's a TCP. No need to explain the fields. Basically, all the useful information is in there. And we suddenly had this for all our systems, which was very cool. So one of the things, so all this stuff's being streamed in, one of the things we get Logstash to do is to change the host field, because all this stuff comes as with the host field set to the HAProxy. But we get Logstash to parse those logs, extract the actual back-end machine, which is like carbon, and substitute that name for the host name. So it looks downstream as if those logs came from the system that handled the request. So that's cool. We also parse out request URLs, decode the URL parameters, and it's all fancy. Now there's a few pages of configuration for this, but this is kind of the guts of it. We strip off any fragment part. We then do a key value split to get the parameters. URL decoding we used to do, it's currently disabled owing to a bug. If the responses are 500 or 400, we tweak the severity level so they show up more easily. Then we remove the parameters from the request, since it's kind of extra detail, we've already parsed them out. And we replace the message with something more humanly readable, which I'll show you in a sec. So this is great. We now have detailed TCP and HTTP traffic logs, but we're still parsing the log messages. Still hard to handle multi-line messages. They're a real pain when you're trying to parse log files. We still don't have enough contextual information, so it's kind of great. We've moved forward, but it's not ideal. How much time do I have, by the way? I think I end at 10 to? Okay, need to go faster. Right. Parsing textual log messages to extract information that your code put in there is just dumb. So what I want to do instead is log JSON. Wouldn't that be cool? And that opens the door to throwing extra information into the JSON. And as a bonus, it also serves the multi-line message problem. You're no longer trying to parse multi-line messages out of your log file. So I wrote this module and released it just a week or so ago, which is a JSON layout for log4Perl. This turns out to be really good. So you specify which fields you want included, so you'll recognize these. These are the same things that were in the message previously. You can specify a prefix here, which is used, it's kind of a standard way of saying, hey, what follows is JSON. So it's a way of flagging the fact that there's JSON in this particular log message. So what you get is a message that looks like this. So there's the timestamp, facility, severity, program name, process ID, there's the prefix, and then here's the JSON hash. And new lines get encoded in JSON as \n. Yay! And then source file foo, da da da. Now, this information, the source file and the subroutine and the line number, used to be just thrown into the message. We used to edit the message. Now we don't. They can be passed through separately. That's cool. So in Logstash, we extract this back out. We recognize this prefix, grab the data that follows, say, oh, yep, we tag the message as being of this type. And if we have that tag, then we use the JSON filter to decode this data and delete it. So that takes the JSON fields and pulls them out and adds them as first-class citizens, you might say, within the message as it's passing through Logstash. This is great. So we now have JSON log messages, multi-line messages are being handled, but we still don't really have enough context. The only context we have is those ones that we added of the Perl source and line number stuff, but kind of the door has opened. We can start doing more interesting things. So this idea of context data, of what was the system doing when it generated this warning or error. So I think of it as like the ambient information. It's particular pieces of information in the context of the process and that identify what work was being done. And we'd like to make it available in any log messages or automatically, including warnings and exceptions. So imagine this piece of code where you're in some loop, some sort of important loop at the part of the program, and you're doing something with this foo ID. And then you call the subroutine, and that might be doing all sorts of things. And somewhere in there might be warnings generated or log messages, whatever. And you'd like this foo ID included in those messages. What do you do? Yeah, so this was the problem I was trying to solve. So I thought, well, we're logging JSON now, so if we put that ambient information that we care about into a hash, and then include the contents of the hash into the JSON message, and then we can use local to limit the scope, because down here, we don't want the foo ID still to be included. So this is what we end up with. This is all you need to do. So this log context is a function that returns a hash reference. You put the key and the value, and you use local. And then at the end of the scope, it disappears. Now, any messages from here, log messages, warnings, errors, will all include that data. Log context, terribly complicated too. We use this thing, part of log4Perl, called MDC, which is it's just a hash. If you use some other logging system, you can do the same kind of thing. It's basically a reference to a hash, just one hash. And then in order to enable that in the JSON layout, you just include MDC. So all you have to do. And now you can log all sorts of useful context information. Now by default, this foo will be added to the top level hash. You can also optionally put all this stuff, whatever you put into the hash, you can give it a name and then it'll all be embedded sort of further down. So you can play it either way. If you do it this way, you have the advantage that you could put into the hash things that override other fields if you want to lie about something. So we have an easy way to add contextual data. Arrays and hashref works, but best to keep it small because whatever data you put in there is going to be copied in every single log message. But what data should we include? Should we add the request URL, the decoded parameters? You know, it'd be expensive to add that stuff into every single message. So we have a stream of HA proxy logs and we have a stream of application logs. Yeah. We'd like to be able to tie them together and say, well, what HA proxy request was the code working on when it generated this message? So rather than trying to dump request information into the like the request URL and parameters, what we could do is add a unique ID into the HTTP logs and HTTP header. Let's see how that works. HA proxy again, you define a unique ID, that's just the standard one that they recommend, and you say, I'd like you to put this unique ID into an extra header. So as the request passes through HA proxy, it adds a new header, and then this ID field is what makes that ID get included. So HA proxy now generates a unique ID for each request, adds it to the request as this, includes the unique ID in syslog message. So suddenly you have the same ID going in both directions. You have the ID going in the syslog, and you have the ID going in the request. So then you can have Plaque middleware, for example, that grabs the header value and sticks it into your log context. So we have this Plaque middleware, dead simple. It's usually the outermost bit of Plaque middleware. First thing it does, completely resets the log context and just puts in the ID. So now, given any log message from a web app, we can find the request that was being processed at the time. This is awesome. And also, because we can find the request includes the session cookie, which means we can jump from the session cookie to all of the clicks in that session, all the requests that that user made. Isn't that cool? So you have an uninitialized warning, uninitialized variable warning, for example. You can go back to the request and to the whole click stream. Demo. Okay, how am I doing? 42. Right. Now here we have, now this is our staging environment. So, Black Oak, I'm going to click on Black Oak there. So, Black Oak is kind of a asynchronous message queue thing. Now what I didn't show you before is down here you can see a whole bunch of messages. Our staging thing, it's only one little poor machine and it's struggling at the moment because our Puppet setup has gone a bit crazy, so there's a whole load of messages coming through. So now you can see over here, I've asked it to show a couple of parameters. Let me, these are the various fields. You can, if you click on one of these, you'll get a little sort of micro-analysis of all the variations of the values of that particular thing. And you can click on this and turn it into a pie chart. And then it gets added up here. And you could dismiss that, or you could grab it and drop it as a separate thing. So it's the kind of thing Kibana makes really easy. So you can drill down and really customize a view of whatever problem you're working on and then share it with others. Dead cool. Okay, now if you click on one of these messages, like this one, you can see all the fields. Now, some of these come from Elasticsearch itself, some of them come from Logstash, some of them are in the original message. Now, in this particular case, because it's a staging environment, we captured the original message. This was the text that went into Logstash. And you can see in there the extra sublog, log info, source line, etc. You can also see the message. And then here you can see the gisted message. Here you can see the numbers being replaced by an N. You can also ask to look at the JSON. And here you can see there is the TLX ID for that request. And here is some data that this message queuing thing, this was its context data. So that gets logged for every message that comes out. Now, what I can do, now, if I take one of these messages like this one, go back to the table, go down to the TLX ID. If I click on this, it'll say, only show me things that have that TLX ID. And bingo, there's the message, and there's the request that was being worked on. at the time. So here you're correlating a message from an application with the particular request that generated that message. There's all sorts of more awesomeness I could show you about all that, but I think we are out of time. So, questions? Yes.
Have you considered using serial instead of JSON?
Have I considered using an unreadable binary format instead of a very readable JSON? Serial is awesome, completely awesome at many things, but it's not awesome at human friendliness and processing by Logstash. Well, so Logstash has many different codecs for interpreting different formats, but there isn't a serial codec. And even if there was, I think I'd stay with JSON. Because JSON for logging has a particular advantage that it has this natural line format where you can put the entire JSON message into one line, and any embedded new lines just get encoded as \n. So it's a very natural fit for logging and for Unix tools and piping and grepping. So it makes JSON a very appropriate format. Yeah. Any issues scaling Logstash? We've done pretty well at the moment. So the 3 machines are processing 200 messages a second in production. Occasionally going out. Oh, actually, I can show you Marvel. Marvel is Elasticsearch's monitoring application for Elasticsearch. So here you can see we have a cluster of three machines. We're currently processing 400 and odd messages per second. Very low load. So it's grand, working very well. This is Logstash 1.4.2. I think there's a new version of Logstash about to be released that has much more optimization. They've been working on the optimization. Also, at the moment, our filter chain only has a single thread because we want to use the throttle that we rely on for IRC has a bug with multiple threads. So that's being fixed. So then we'll be able to use multiple threads for the worker, and then there wouldn't be any problem. So occasionally at the moment, if at peak times, there might be a backlog. So our syslog will build up a backlog as it ships. So I think we're doing well. Yeah, for 3 ordinary-ish VMs. Yeah. I'm happy with the performance, let's say.
How was the learning curve to understand Kibana? I have the impression what you are doing here is so miraculous. I can't imagine I would ever learn to use that.
Okay, what's the learning curve for Kibana? You know, practically everything I've done here is trivial. You know, Kibana can do much more than I've even bothered to learn about. And I kind of knew that there was a new one coming that would be different. It's using newer features of Elasticsearch. So the whole lot, there's kind of a new generation of this tool, this tool chain coming out. So I only did very basic customization. But all of these things, you can click on this, you can view the JSON that's sent to Elasticsearch as the query. So you can notice that query it's formatted as a curl command. Yeah. So you can copy and paste that and run it on the command line to repeat exactly what data that widget is looking at. And all these things you can pick them up and you can move them around, and then when you've got it just the way you want, you just save it. That's my dashboard. You know? So I'm quite sure there are many more features that I haven't got into yet. And I'll make the effort of getting into them when we're using the next version of Kibana. Logstash was probably harder to get the hang of, just a few little road bumps, because we're making good use of it now. You know, I've kind of squeezed a lot of functionality from it. But that was a little more tricky to get comfortable. There's just, you know, simple questions like, if you have an if statement, what constitutes true and false? It's not actually documented, so I opened a case to say, document that. And Elasticsearch has quite a learning curve. It's a lot better now than it was, but when I started with this, Elasticsearch was still very young, sort of 0.20. But it's a lot better now. And there's a huge community around Elasticsearch and Kibana and Logstash. So there's loads of resources, presentations, slide shares, talks like this. 1 minute, I'm being told. 0 minutes. Okay, last question.
Slides online?
Slides online, not yet, but they will be. Thank you very much.